This video presentation is brought to you by the Pro Mathematics Academy. Welcome back to another video presentation brought to you in part by the Pro Mathematics Academy. In this video, we'll be looking at the inverse of a matrix. And when we talk about the inverse of a matrix, we say that for a given matrix M, the inverse is defined as m raised to the negative 1 power, so that when I multiply m times m raised to the negative 1 power, it results in the identity matrix. Okay, so we say let m be born, and if m is equal to a, b, c, d, right, let's find m inverse, the soulmate of m. Okay, but we don't know what the soulmate is, or even if the soulmate exists. So let's define m inverse to be equal to a star, b star, c star, and d star. Then we're going to try to use the equation from the definition to try to find the inverse. So a, b, c, d multiplied by a star, b star, c star, and d star should be equal to the identity matrix, which is 1, 0, 0, 1. Taking this product and equating it to the identity matrix can allow us to solve for the inverse, right? But before we solve for the inverse, we have to recognize that we have the product of two matrices on the left-hand side. And when we are multiplying matrices, we must first separate the first matrix into rows and the second matrix into columns. Okay? So now, what we realize is if we're multiplying A, B, C, D times A star, B star, C star, and D star, our first row vector would be AB, our second row vector would be CD, our first column vector is A star, C star, and our second column vector is B star, D star. Now, to get the first element of our product, we will get AB times A star, C star, right? Our second element would be AB times B star, D star, and our third element would be CD times A star, C star. Our last element would be CD times B star, D star. And we have to recognize that in order for two matrices to be equal, terms in the same positions have to be equal, right? So this allows us to equate the first two terms, right, which is AB times A star, C star being equated to 1. This allows us to write down the equation A times A star plus B times C star equals 1, right? And we get that expansion after taking the dot product of the vectors. Okay, equating the second two terms, we end up with A times B star plus B times D star equal to 0. Okay, and equating the third terms, we end up with C times A star plus D times C star equals 0. And if we equate the fourth terms, we end up with C times A star plus D times D star equals 1. All right. Taking the first two equations, we get A times A star plus B times C star equals 1, and C times A star plus D times C star equals 0, right? Now this might be confusing, but we know A, B, C, and D because that is the given matrix, okay? The only thing missing here are the values of A star and C star, okay? So we can use a method of substitution, right? Or we could use the method of elimination, but here we're going to go with the method of substitution to solve a simultaneous system of equations. Okay, so by making a substitution, we're going to transpose for C star in equation 2, right? Which means that I can bring C times A star over to the right hand side of the equation, which gives us D times C star equals negative C times A star. This then gives us C star equals negative C times A star divided by D. Okay, so now once we have this expression for C star, we can substitute that C star into equation 1, right? And remember, equation 1 said A times A star plus B times C star equals 1. So where we have C star, we're going to plug in negative C times A star divided by D. So this then gives us A times A star plus B times negative C times A star divided by D equals 1, right? And now we can simplify. So this means that A times A star plus negative B times C times A star divided by D equals 1, right? Now we can try to get common denominators. So this means D times A star divided by D plus minus B times C times A star divided by D equals 1. We can now put the numerators together because we have common denominators. So this gives us D times A star minus CB times A star all divided by D equals 1. Now we can transpose by bringing D from the left hand side over to the right hand side, which gives us A times D times A star minus BC times A star equals D, right? And now we can factor out A star out of the expression on the left, which means A star times AD minus BC is equal to D, right? And now we transpose for A star, which means that A star is equal to D divided by AD minus BC. Okay? And the good thing about the method of substitution now is that once we found A star, we can go back and find C star. So we can substitute A star into C star and simplify. Okay, so we already know that C star is equal to minus C times A star divided by D. So this means we now end up with C star being equal to negative C times D divided by AD minus BC, all divided by D, which simplifies to minus CD divided by AD minus BC divided by D, right? And now we can cancel D from the denominator and the numerator, right? To end up with C star equals negative C divided by AD minus BC, right? And now we found A star and C star by using the method of substitution. All right. So what I want you to do right now is to pause the video and try to solve the second two equations. Okay. So the second two equations would be A times B star plus B times D star equals 0 and C times B star plus D times D star equals 1. Okay. After solving, you should get B star equals minus B divided by AD minus BC and D star equals A divided by AD minus BC. Now that we found all the terms, right, we have all the information we need to write down M inverse, right? So this means that the mystery matrix we've been looking for, A star, B star, C star, D star, right, can be written as D divided by AD minus BC minus B divided by AD minus BC minus C divided by AD minus BC and A divided by AD minus BC, right? So if we look at this expression, we realize that the common term is AD minus BC, and so we can factor out 1 divided by AD minus BC so that we now end up with the inverse being equal to 1 over AD minus BC times D minus B minus C and A, right? So this expression here is the expression for the inverse of a matrix, okay? This expression here is the expression that is equivalent to the inverse of a 2 by 2 matrix M, okay? So notice that this result is only valid if we are not dividing by 0 in the reciprocal of AD minus BC, right? So the expression AD minus BC is called the determinant. The mathematicians decided to call it the determinant because it determines if the inverse exists. All right? That's it. That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.